Good morning, children. Thought for the day. When you move your focus from competition to contribution, life becomes a celebration. I repeat, when you move your focus from competition to contribution, life becomes a celebration. And so, never try to defeat people, just win their hearts. Okay? So, instead of always keeping in mind that you need to defeat somebody, just win their hearts and you'll find that life is such a wonderful gift. With this thought, let us start the new chapter, current electricity. As you know by now, when you are sitting here, electricity or equipments which run on electricity are all around you. Electricity is of utmost importance in the modern world. We depend on it for almost everything in our day to day life. In order to avoid the inconvenience faced due to failure of power supply, hospitals, banks, offices, and private institutions make alternative arrangement with the help of generators. Electricity is used for running electric furnaces, electric motors, and several other instruments used in industries. Domestic appliances like the fridge, electric oven, mixer, fans, washing machines, vacuum cleaner, roti maker, etc. They have helped us all by saving time and labor. All those devices cannot be run without electricity. Not only human beings, but some animals also use electricity. For example, fishes, such as eels, use electricity to catch their prey and also for self defense. The lightning that strikes the earth is an excellent example of natural flow of electricity. What if we could collect and store this electricity? So, children, electricity is an integral part of our life. Just after the basic needs of food, shelter, and clothing, electricity, as you can see and you can observe all around you, it is also has become a part of essential needs of our life. We cannot imagine life without electricity. Can you recall? You must have seen a waterfall. Which way does the water flow? Of course, you all have seen and observed that water flows from a certain height of a mountain towards the ground. Potential and potential difference. Try this. Set up the experiment as shown in the figure. Then remove the clamp from the rubber tube. Note your observations and answer the following questions. So, you can observe here as the experiment is set up. What happens when the clamp is removed? Just observe. When the clamp is removed, water flows from the plastic bottle kept at a higher level to the plastic bottle kept at a lower level. Does the water stop flowing and why? Yes. As soon as the water level of both the bottles they become equal, the water stops flowing. What will you do to keep the water flowing for a longer duration? In order to keep the water flowing for a longer duration, we must increase the difference in the water level between the plastic bottles. Why? Because when the level of water in both the bottles becomes equal, the water stops flowing. So if you wish that the water should keep on flowing for a longer duration, then there must be some difference in the water level between the plastic bottles. Okay. Potential difference and flow of electricity. positive charge flows from a point of higher potential to a point of lower potential. We have seen earlier that electricity flows due to the conduction of negatively charged electrons. Electrons flow from the point of lower potential to a point of higher potential. A lightning strike is the flow of electrons from the point of lower potential, that is negative, on the clouds to the point of higher potential, that is 0, on the earth. Okay. The difference, we shall study the definition of electric potential in higher standards. The difference between the values of potential at points A and B is called the potential difference between them. As you can see here in this figure 3.2, conductor A is at a higher potential than conductor B. When these two are connected by a conducting wire, a potential difference is created between its two ends and electrons will flow from B to A through the wire. This flow will continue until the two conductors A and B have the same potential, that is, until their potential difference becomes 0. Only then will the flow of electrons stop. Okay, so now you can relate this with the flow of water from higher level to lower level. When the level of water flow in both the bottles it becomes same, the water does not flow. And so also when A and B, they have the same potential, okay, so their potential difference is 0, so no electrons will flow. So there has to be some potential difference, only then that difference will cause the electrons to flow. Okay, so you can see here the two conductors A and B. Okay, conductor A is connected at higher potential, okay, and B is connected at a lower potential, and they are connected with the help of a conducting wire. Now since there is a difference in potential, okay, what will happen? The electrons will flow. Okay, you know that in an atom what are present? Protons, neutrons and electrons. Okay, so electrons are negatively charged particles. Okay, so free electrons, when their potential in some cases higher and another conductor B it is lower. So this potential difference causes the electrons to flow between the two ends from B to A. Okay, and since there is a difference in potential, the electrons, they start flowing. That means the current flows. Okay, because work has to be done, okay, against the electric field to take a positive charge from a point of lower potential to a point of higher potential. Potential difference of a cell. The difference in potential between the positive and negative terminals of a cell is the potential difference of that cell. This potential difference is caused by chemical reactions occurring inside the cell. The potential difference sets the electrons in motion and results in the flow of electricity through a conducting wire connected to the two ends of the cell. The amount of work done to carry a unit positive charge from point A to point B is called the electric potential difference between the 2 points. As you can see here, potential difference between 2 points is work done divided by total charge transferred. Work done is given by W and charge is given as capital Q. And now the unit for potential difference is volt. So 1 volt unit for work is 1 joule, and for charge Q is coulomb, that is C. So the unit of potential difference in SI system is volt. Okay, as you can see here, nucleus is present, electrons are present in the orbit around the nucleus. The weakly attached outermost electrons, they are able to move. Okay, So the free electrons, they move freely from one atom to the other atom. Okay. So when two charged conductors are joined by a metallic wire or they are placed in contact, the free electrons, they flow from a conductor having more concentration of electrons to the conductor having less concentration of electrons. And potential is an electric state of a conductor which determines the direction of flow of charge when the two conductors are either kept in contact or joined by a metallic wire. The electric current flows from a region of higher potential to a region of lower potential, that is in a direction opposite to the direction of flow of electrons. And potential as work done by unit charge. The potential at a point is defined as the amount of work done in bringing a unit positive charge from infinity to that point. Okay, so the work needed to move a charge Q to a point P where the electric potential is V. Okay, and hence it is given as W is equal to V multiplied by Q, or potential difference is given by work divided by charge transferred. And the potential difference between the 2 points is equal to the work done in moving a unit positive charge from one point to the other. Okay. An introduction to scientists. The Italian scientist Alessandro Volta constructed the first electric cell. The unit of potential difference is named volt in his honor. Volta's simple electric cell. Do you know very small values of potential difference are expressed in the following units? Okay, so 1 volt is made up of 1000 millivolt. Okay, so 1000 millivolt, they make 1 volt, and hence 1 millivolt is 1 divided by 1000, that is 10 to the power minus 3 volt. And 1000 microvolt, they make 1 millivolt, and hence the value of volt becomes 10 to the power minus 3 multiplied by 10 to the power minus 3. So the power gets added, it becomes 10 to the power minus 6 volt, microvolt. Okay, again I repeat, 1000 microvolt, they make 1 millivolt, and 1000 millivolt, they make 1 volt. Okay, so 1 volt is 10 to the power minus 6 microvolt and 10 to the power minus 3 millivolt. And the large values of potential difference, they are expressed in the following units. 1 kilovolt is 10 to the power 3 volt, and 1 millivolt, megavolt is equal to 10 to the power 6 volt. Okay, so here 1000 volt make 1 kilovolt, and 1000 kilovolt, they make 1 megavolt. So these are large values of potential difference and small values of potential difference.